Hello, welcome again as we do another one of these things. Uh, let's graph linear equations. Oh, there should be a slash right here. Should have known. Oh well, let's put a slash here. Great. You're graphing linear equations and functions. Now, uh, we did some of the stuff in class. The worksheet that you guys were doing was just dealing with the quadrants and stuff like that. And really just understand from here, you have quadrant 1, 2, 3, and 4. So that's pretty much what you got to know about the grid, like where the things is. We'll be spend a lot of times with the word problems. We'll be spending time here, but we'll get to all that. I don't want to put that now. Let's just move forward to what we need to do. Here, when you're talking about a linear equation, a solution to a linear equation is just an ordered pair xy that makes the equation true. For example, if I asked you which ordered pair is a solution to this equation right here, I agree it's a linear equation. Linear equations in standard form kind of look like ax plus by equals c. So this right here is being a linear equation. How can I tell whether or not the solution given is a true statement? I can just plug it in. Let's find out for a. If I plug in a, obviously you can see it's not true. The reason why is I plugged in 3 for x, 4 for y, and when I plug that into the equation right there, I ended up with an untrue statement. 9 minus 4 is not 7, so we know it's not that one. What about b? That works because it gives us a true statement. This is a true statement right here. So because of that, we found what we needed to. So we know that this is a solution to it. But we know that A isn't, and probably C is not. Neither is D. So really all a solution is just a point, a value of x and y that make my linear equation true. Now, oh well, actually, let me say this. When you're talking about a linear equation, the word that I want you to look out for in a linear equation, when something's linear, the root word in linear is line. So all it is the equation of a line. So with an equation of a line, it means if I graph it, I'm going to get a line. Say if I want you to graph this equation right here. Now, unfortunately, with this right here, we'll have to graph it. We can't necessarily graph it by hand like that. So the form that I always graph in is y equals mx plus b. You guys have to be familiar with that form, right? So to put that in this form, you solve the equation for y, right? So if I solve the equation for y, now I have y equals 2x minus 3. Now it's claiming it wants you to make a table and all this other stuff to plot the points and things. You could, for now, if you made a table to plot the points, let's see what happens. I like to do -1, -2, -1, 0, 1, 2, and find the values for that. So really each one of those, if I plug it back in, I want to see what I'll end up with, right? So what I'll end up with, if I plug in that 1, it'll go like this. As I showed you, all I did is I took that 2. When I plugged that -2 back into our equation, when I plug that -2 in there, you got -4 minus 3 gave me -7. That's going to be my y. In other words, as we discussed before, I inputted x into the equation, and out came -7. I inputted -2 into the equation, and out came -7. So with those points, if I plot those points, see -2, -7. Notice that they go in a straight line. So really those points, well, when I plot the points and I draw a line through those points, like so, there's a line that goes straight through those points. And what each one of these points represent are solutions. Each of these points are solutions to this equation. Now, if you don't see that, let's say if I write the equation over here that we have, negative 2x plus y is equal to negative 3. And I plug in one of those points. Say I plug in negative 1, 5. Say if I plug in the point negative 1, 5. That's negative 2 times negative 1 plus 5. We're going to see if that equals negative 3. That's going to be 2 plus 5. Hold on, wait a minute. I'm sorry, that's a negative 5. That's why. Would that be a negative 5? 2 plus negative 5 is going to equal negative 3. So it gives us a true statement. So it works as a solution. Same thing with all the other points I highlighted and everything in between and on the outsides of it. But we'll get to those in a second. If I wanted to graph these equations, say graph the equation x equals 1. If you have an equation, anytime it starts with x equals, then you're talking about a vertical line. Reason why I say that is because it says x equals 1. So think about all the points where x equals 1. So you mean 1, 2, 1, 4, 1, 10. So on every single point where x equals 1. So if we talk about it, like say here, we know 1, 0 is one of the points. So is 1, 1. How about 1, 2, 1, 3? Now you see what kind of line it's forming. A vertical one. So I just wanted to point out to you, if x equals, anytime you see an x equals, it's talking about a vertical line. Y equals, it's going to be a horizontal line. So anytime you see a y equals, it starts with y equals, and you just have a number on it, just like with x equals you have just a number, you're talking about a horizontal line. The reason why is because, say here it says y equals 2. So the points you're talking about, right, is every single point where y equals 2. So that's anything. Let's say 1, 9, 8, all of them. So let's make sure we actually have those. If we're doing 1, 2, that point goes here. 9, 2, that point goes here. Well, okay, 1, 2. Let's actually do that big. 9, 2, 8, 2. So you can see my point. Every one, as long as my y coordinate is 2, then we all know what kind of line that's going to make. A horizontal line, right? So, alright, we dealt with graphing things like that. I should show you this graphing now. Horizontal lines, vertical lines. When you have y equals, horizontal. X equals, vertical. Right? Now, let's actually go back up and let's establish something else. When we were here, right? A problem that I did before, even better. Remember when we talked about domain and range of a function? When we talked about a domain and range of a function, we said that the domain was all possible x values. In other words, all possible inputs. And the range is all possible y values or all possible outputs. So say, for example, this right here, this set of points right here is a function. Well, of course it's a function. Now, the domain of that would be 1, 3, and 6, right? The range, though, would be 2, 6, and 12. So you see where the domain is, you see where the range is. Now, if I plotted this, right, on a graph, all you have is 1, 2, 3, 6, and well, 6, 12. 6, 12 will be like up here somewhere. I should have picked a better point. But my guess what I'm trying to get at is here the domain is given to you, and the domain only has 3 numbers in it, right? So it doesn't, all it really talks about is that point, and that point. But see, what if the domain was a little bit different? What if you had a line? Now you're counting, if you had a line, now you're accounting for every single point on this line. And that's too many, that's an infinite amount of numbers. It's way too many numbers to actually write. So in this case, when you're talking about your domain, if you have a line, a continuous line like that, then now your domain is, remember all your x values, right? But your x values greater than, what's that? The lowest x value we have is 1. So your domain is all numbers x greater than 1. Now you can account for it with a lot more numbers. You get what I'm saying? So let's use that to the other part we have here, where it says an equation ax plus b, all that good. Let's actually get down here. A domain, if it's not specified, your domain is everything. The problem up there, we start out with 3 numbers, and then when I put on the line, you're talking about a whole bunch more numbers. But what if we do specify? See, if we graph the line, just like how we graph these lines right here, your domain is everything. When you graph this line right here, your domain is pretty much all numbers. That's why it goes from the arrow pointing from one place to the other place, right? I don't know why that's there. Let's put that down there. So, same thing with this line. You know that you have the x pretty much is defined everywhere, but if it's not defined, that's what we're going to assume it is. What if we do define it? What if we say that the function y equals -1/2 plus 4 has a domain of x is greater than 0? First off, if we're graphing this line, the part that you guys are familiar with a lot is of the form y equals mx plus b, where m is your slope, b is your y-intercept. So I think those are the parts you guys are familiar with. So that's what b is, and m is the slope, right? So if b is 4 in this case, that means 4 is your y-intercept. In other words, that's where it intercepts the y-axis. Since this is the y-axis, he has to intercept it right there. And then what this is, m, is my slope. So if that's my slope, it tells me where I can go from here. Not there. It tells me where I can go from here. Now I can go up 1, over, nope, that's not what it tells me to do. My slope is -1/2, so it tells me to go down 1 over 2. There goes my next point. I'll do it again. Down 1 over 2. And I can draw a line through those points, right? So let's see. Now I have a line through those points right there. But my domain x is greater than or equal to 0. Now what you should see is x is pretty much, you're talking about the x-axis. So pretty much like, say if I'm here, x is -5, going to -4 to -3, -2, getting bigger and bigger, right? And here we're at 0, right? And then we go 1, 2, 3, 4. Pretty much that's your x-axis. That's what we mean by x getting greater and greater and greater as we go along from left to right. Now what the domain says is that x has to be greater than or equal to 0. So what that means is that we're only talking about the part of the line where x is greater than 0. You're only talking about the part of the line where x is greater than 0. Not the part that's not. The other part we're not talking about. So those aren't in our domain. So really those values aren't even there. So we can just erase that. So the line we're talking about is just that piece. That piece of line right there is the line we're talking about. Domain, notice that all the values of x for the line is greater than or equal to 0. Take for instance this point. That right there is 0, 4. This being the x coordinate. Is it greater than or equal to 0? Absolutely. Keep going down. This point right here, that is 2, 3. This is the x coordinate. Is that greater than or equal to 0? Absolutely. But at this point as well, this point as well, this point as well, this one, so on and so forth. So we're talking about all the numbers x greater than, as long as that you're in the domain, that means you're part of the line. I'll show you one more just so you can see what I'm talking about. Here, graph that function. We have this function right here, and with the domain x is less than or equal to 0. So if I do that, first off, let me do my y equals mx plus b thing. Y equals mx plus b. Remember, m is your slope, b is your y-intercept, right? In this case, your slope is -3. And your y-intercept was 1. Right? So we can actually draw a line based on those things. If my y-intercept is 1, I'm intercepting the x-axis at 1. And then from there, going to slope is -3, which is -3 over 1. So I'm going down 3. 1, 2, 3 over 1. That's one of my points. 1, 2, 3 over 1. That's another one of my points. So on and so forth, right? So now see if I can draw a line to connect all those points together. Now notice, once I draw that line, remember what my domain is. My domain is x is less than or equal to 0. If my domain is x is less than or equal to 0, that means that this line has to be less than 0. The points that I'm talking about are all over here. They're all on the left of 0 because it says x is less than or equal to 0. So because of that, everything that is not over there, everything that is greater than 0 is not part of our line. So we get rid of that. So we're talking about just let's get rid of all up. I'm coming. So we're talking about everything less than. It won't erase. You're talking about all those parts. So notice you're just talking about that piece of the line because it's where x is less than or equal to 0. We'll do more of this stuff in class. This video is actually kind of long. I'm sorry about that, but now it's over.